Hello Cloud Gurus and welcome to part 2 of the Data Model version 1 design lesson for the Learning Online case study. This lesson will continue from part 1 and help you build up a complete picture of why some of the decisions have been made which surround this data model. Now, based on the previous slide, I already have a candidate set of tables and they may evolve over time, but at the very least, they're technically viable. And for now, that's a great first step, and it will allow us to assess the viability as we proceed through the course. Now, the next step is to pick keys for the tables. And as you have learned, we've got partition and we've got sort keys. Together, they have to be unique as they uniquely identify an item within a table. As a general rule, you can use an existing attribute if one exists which is unique, either in isolation or together with another attribute to make a partition and range key pair. If you're using a pair of keys, remember that the requirement is that both of them together needs to be unique. If you're just using a single key, then that key on its own needs to uniquely identify an item. So let's discuss my initial key choice. For students, I mentioned that we're storing a large number of student details, and one of these was government ID. When thinking for a suitable key, it struck me that a government-issued ID is an ideal candidate as they are generally unique and so would identify the student perfectly. Additionally, many of the searchers on students would likely use this ID as the query target. So again, it's a win-win situation. It's an ideal key to use. The problem is that while we can fairly certainly guarantee that a government ID is unique in the country that it's issued, we can't be 100% sure that countries use non-overlapping namespaces for those numbers. Do we know, for example, that America's driving license numbers don't overlap with Australia or Mongolia? What about Ethiopia and Brazil? It's risky, and so my thoughts are that it was better to pick something that the system generates so that we can ensure the uniqueness. Now then we moved on to teachers, and the teachers was the same logic. We could have used government ID, but I can't guarantee the uniqueness, and I want to ensure that the data model in its initial form has as few problems as possible. So again, I decided on a generated ID. Courses presented a different but similar problem, where we store the name and description of a course, but we can't guarantee that it's unique. Even if we assume that the course name is unique, for example, Maths 101 is likely not to be used twice, we run the risk of running out of sensible names in that particular namespace. So again, a generated ID seems logical at this point. For course instances, we know that we may have more than one course instance for a given course. It's a one-to-many relationship, but there is a link between a course instance and a course. In deciding this one, I gave some thought to the data retrieval needs. Admin staff potentially need to regularly access all of the course instances for a given course, and we need to do so effectively. I haven't taught you yet about how retrieval works in DynamoDB, but at a high level, we can pick an item or multiple items by specifying a partition key and or a sort key. So I decided on using a course ID as the partition key, and this together with a sort key would allow us to retrieve all course instances for a given course or limit it by using the sort key. So a logical sort key to use would be the year. Then we could do the search based on the course ID and then specify a year and then retrieve an item that matched. But what if we had multiple instances for that course in a given year? Ideally, we'd be able to have 3 keys, one being the course ID, one being the year, and one being a course instance ID. But in DynamoDB's case, we're limited to 2 keys, partition and sort. However, we can also concatenate data together and use that as a generated key. For example, we could have a concatenated sort key of year and then a hash and then an instance number, and this would allow the system to cope with multiple course instances in a given year. And we could also then, provided we have the course ID, filter and display any courses on a given year by just taking the year ID and then concatenating 1, 2, 3, 4, 5, and 6, and so on. So we could very easily pragmatically list all of the course instances for a given course ID and a given year. So it seems to make sense that the year, and then a hash, and then an instance ID number, i.e. 1, 2, 3, 4, and 5, makes sense as a concatenated sort key. Later, you will learn about indexes and how non-key values can be queried against. Right now, you may look at the year, hash, and instance and think that it's a good key, and for our immediate needs, it works well. However, course ID, hash, year, hash, instance ID provides additional flexibility that I will detail later on. So you need to just trust me at this point, and I'll explain why in later lessons, but I'm going to go with course ID, hash, year, hash, instance ID. And when I talk to you about indexes in later lessons, it will make complete sense. With modules, we store the module name, the description, the teacher assigned to it, and the standard pass mark. While the module name could be unique, again, we don't know if there is going to be contention in that namespace. For example, if we have trigonometry 101 and then calculus 101, we don't know if we're going to run out of names to use in that space. And so in this case, I want to stay on the side of caution and generate a unique ID. Exam is a fairly interesting one. There aren't any other attributes in the table that lend themselves to being used as a unique identifier for an item. And it makes sense that we'll generate an exam ID that we'll use as the unique identifier for the table. I've considered other combinations such as booking ID, student ID, course instance ID, and we're going to run into issues where, because we only have 2 keys, no set of those 2 keys means that we can guarantee we won't have duplicate items. And so again, it just makes complete sense to err on the side of caution and use a uniquely generated ID. And lastly, we have the attendance table, which records for a given booking the date and time a student scans or logs in or out of that booking. This one is ideal to use pre-existing keys by picking the booking ID and the student ID. And we have an architecture that is unique without needing any generated values. Now you'll notice an ongoing theme of using generated IDs for a lot of the partition keys in these tables. Now, as a best practice, there's nothing wrong with using a unique random generated ID as the partition key. As you proceed through the next couple of lessons, you might get a little concerned that a lot of the retrieval operations that you'll use, the simple retrieval operations such as get item and query, and I'll talk about those shortly, they use a partition key to select an item. And it will become obvious when we start talking about it that you may not know the ID of a student when you want to pull the data of that student. And your concern may be, as you learn about query and scan, that we're going to limit the efficiency of our retrieval operations based on picking a generated ID. When we talk later in the course about indexes, these will put your mind at rest because it will become obvious how we can have alternative representations of a table and we can query information from those indexes using other attributes. So for now, there's nothing wrong with picking a generated ID as a partition or a sort key. So based on the last 2 slides, we generate 7 tables with the names shown below: students, teachers, courses, course instances, modules, bookings, and exams. Now you might notice that all the tables are prefixed by low and an underscore, and that's always best practice. DynamoDB doesn't have the concept of databases. Any tables in a region in your account compete for the same naming namespace. So it's always best practice to tag tables for certain applications with a common starting name block, i.e. low underscore or weather station incorporated underscore or weather underscore. Pick a value that fits the project that you're doing and tag all of your tables with that tag. And that means that when you're using describe tables and list tables, or you're working in the UI, it's really easy to see the tables that belong to a specific application or project. So that's my logic in picking low underscore before each of our table names. Now, one of the key questions I raised at the start of this lesson was to think about data growth and how this impacts the model. I don't expect you to have an understanding at this level of detail yet, but for now, just know that these are the tables that are likely to experience regular and high quantity growth. Out of these, students, teachers, and exams are likely to cause the biggest impacts as these tables contain the most data. Students and teachers will contain binary data for the ID picture scan for each student and teacher, and exams can contain entry and exit pictures, as well as a scan of the physical exam papers if the student is attending the exam in person. So keep both of these things in mind as we move on. So this is the final version 1 data model. You should take the time to become familiar with it, as it will be used in an evolving form throughout the course. There are a few things I want to draw your attention to. First, you will notice that on the whole I've used strings rather than other data types. Strings in DynamoDB are flexible in that it's easy to pragmatically perform operations on strings. They can store leading and trailing zeros, and I find it easier to keep a consistent data type. Now, this is not strictly best practice, but it's something I do, so you should just decide for yourself at this point how you want to proceed, but at least for a proof of concept or a case study such as this, we can safely use strings. The only time I use numbers is where it's clear that there is a potential for numeric operations to be performed on attributes, i.e. capacity or passmark. There are also a few lists, and where appropriate, they are a powerful data type to use in DynamoDB, used when sets of items or lists are required to be stored. You will notice that I've used strings for dates. Now, this is very much not best practice. I'd only recommend that this is used within proof of concepts where the date field needs to be readable in the console, as in the case with this course. Under 99% of circumstances, the best practice convention here is to use the number attribute and store the date in seconds or milliseconds since epoch, the Linux standard for timekeeping. Pay attention to the red cells, as these store actual binary data, ID pictures, entry and exit scans, or copies of physical examinations. We'll discuss this design choice together with its limitations and ways to improve this during the course. Lastly, I've proposed the use of manufactured IDs for many of the partition keys. How are these going to be manufactured? How do we ensure they're unique? There are many ways to accomplish this, but for the version 1 data model, we're going to use a non-ideal method because I'm going to use it to illustrate some problems with doing it in this way. Many databases have a way of using a counter for an attribute, a value in a column that is incremented each time a row or item is added. DynamoDB doesn't have this ability, and so I'm going to use a counter table. This table will have one item for each of the counters, one for each table that uses a generated ID as its unique partition key. So for example, SID represents student ID and TID represents teacher ID. Anytime an item is added to the table, the value for the relevant counter is retrieved, incremented, that value is used for the table write, and then the new value is written back to the counter table. Keep in mind, I know this is not ideal. I'm using it very intentionally to demonstrate to you some of the problems that can occur when using the counter table architecture. And we will refine this during the course. Okay, so I hope that everything is logical so far and you have a basic understanding of how we've designed this data model. If you don't understand, or you have questions that you'd like to pose or discuss with me, I absolutely encourage you to create a thread on the Cloud Guru forums and we can discuss it further. In most cases, you will see that the choice is intentional, designed to illustrate something, but I am very happy to answer any questions you have or debate any choices made. If you come up with better ideas, we can improve the course for future students. Thanks for listening, Cloud Gurus. This is the end of this lesson. If you have any questions, feel free to reach out directly or via the Cloud Guru forums. Otherwise, go ahead, complete this lesson and move on to the next.